Hi everyone! In this video, we will solve equations with decimal coefficients. Here we have an equation with lots of decimals. Decimals can sometimes get kind of messy, so there's a trick to getting rid of all of the decimals in any equation. The trick is to count all of the decimal places. Here we have 2, 2, 2, and 2. In this case, it doesn't matter. However, we picked the largest one, and in this case, it's 2 for all of them. So the largest one is 2, and we multiply both sides by the multiple of 10 with that same amount of zeros. So a multiple of 10 with 2 zeros is 100. So we'll multiply this side by 100 and this side by 100. We'll need to do the distributive property to make sure that every term is multiplied by 100. When we multiply by a multiple of 10, this moves the decimal place the same number of zeros. So 100 times 0.16 moves the decimal place 2 place values to the right, making this 16s. Again, multiplying 100 times the 1.25 will move the decimal place 2 place values to the right, which makes this plus 125. The same thing happens on the right side. 100 times 0.24 moves the decimal place the same number of zeros, so it makes this 24s. And the last one, 100 times 7.25, moves the decimal place 2 place values to the right, making this 725. Now we need to combine the terms with all of the variables on one side of the equation. It doesn't matter, so I'm going to go ahead and subtract 16s from both sides, moving all of the variables to the right side. You can pick whichever you prefer. 16s minus 16s cancels, so we're left with 125 equals 24s minus 16s gives us 8s plus 725. Now we need to continue isolating the variable by subtracting 725 from both sides. 725 minus 725 cancels. 125 minus 725 gives us negative 600, which equals 8s. And now we need to divide both sides by 8 to cancel out the 8. And we're left with s equals negative 600 divided by 8 gives us negative 75. It's recommended to substitute this back into the original equation for every variable so that you can check to see if you get a true statement. I won't be demonstrating that on this example, but you can try it on your own. And we're all done.